Hello, in this Easter time I invite you to get to know some techniques and functions in generative components. And to make it more joyful I will use Easter egg shape as a base. Let's start. Of course we need to start our project with base coordinate system. Then by creating points related to new coordinate system we are creating egg section. The base of egg will be related with separate coordinate system so we can later reuse that shape by just copying and changing coordinate system position. In the next step, I'm creating a surface by curve revolution. As an input, we need to put curve. In this case, we used half of our curve and rotated by z direction of our coordinate system by 360 degrees. Now, when we have base shape of our egg, we can start paint it. Let's create a new coordinate system connected with previous one, and by using universal transform technique, we will create a set of coordinate systems located in the same position but scaled. For this, we used x, y, and z scale input and series by count function, which allows us to select minimum, maximum value, and an increment, which value relates to a slider node. Next step is simply copy transform geometry contents. We selected our main egg geometry and copied it from main coordinate system to those scaled one we just created. We can control number of eggs geometries inside the prime one. Let's move to the next egg. We will repeat first few steps to create main geometry. In this example, we will cut our geometry with random planes. To do that, we will create coordinate system by Cartesian coordinate techniques, but in Z translation, we will create a list of random values. We can directly put the value in the Z translation input, or first, what I recommend, in expression node to check if function works correctly and then connect it with the Z translation input. Here's some explanation. So I will go and create new expression node. We will use field list function. First value is the number of list members. Let's type in 3. After comma, we need to put a member value. If we put 5, we will get a list of 3 members equal 5. As we want to have a random value, we need to use a random function. And here one more explanation. If we put only random function like this, it will select only one random value from the range 1 to 10. So we would obtain a list of 3 members equal the same random value selected from a range. You can see when I'm updating model, random value is changing. To obtain the list of different random values, we need to use lambda, which assign new value as many times as we indicate. So, in this case, we will have a list of 3 random values from range 1 to 10. And once again, we can update model to see the results. Okay, come back to our expression. I will delete that one with explanation. So in our case, we are going to use slider to control the number of list members. Then we will use lambda to assign to each member new random value from range 1 to z value of the top point of our geometry. Additionally, we can put remove duplicate at the end of expression, because we don't want to cut our geometry twice with the same plane. Every time we will refresh our model, a new list will be generated. In the next step, we are creating the solid from our surface, and then we will cut it with trim solid with plane technique, where as a trimming plane input we will use XY plane of our random coordinate system. Let's move to the next egg. Once again, we will copy base geometry and only change location of its base. In this example, we will use scaled coordinate system and in the same time rotated one. To do this, we will use additional Z rotation input and connect it with slider node to control it later. And as before, we will also control X, Y, and Z scale. Next, we will create a copy of geometry section and transform it from main coordinate system of it to our rotated coordinate system. Now let's play with colors. We will use ColorGradient node. Let's see how it works. First, we need to indicate which value will determine the position along gradient. Then, minimum and maximum value. We can put a proper value or read it from node output. As we play with parametric geometry, I always recommend to create dependencies between elements, so when size of a geometry will change, all those values will customize. So we will use here also area output of our B-spline curve, but we will evoke minimum and maximum function. At the end, we need to wire the value output of our gradient node with color of B-spline curve. We can do exactly the same with our first egg. Okay, let's move to our last egg. We will create a set of points on our surface by using U, V parameter. We will put series function in U and V input to create a grid of points. When we change replication style to parallel and connect those points to create a curve, we will obtain kind of ribbon on the surface of our geometry. Now let's create rotated coordinate system as before and copy of our ribbon related with a rotation of it. Now we can colorize our nodes on the graph to segregate appropriate nodes. And we have our eggs ready. Now we can add additional slider node and use it as a scale for all eggs by connecting it with X, Y, and Z translations of points which create geometries. Okay, let's play with our whole geometry. For easier control, I will open Control panel, which is available here in the primary tools. Here you can see all slider nodes available in the model. By simple slider move, we can control our changeable geometry. Thanks for watching and happy Easter!
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.